Hello, my name is Richard Everitt. I am the Principal Investigator for the grant Statistical Inference and Uncertainty Quantification for Complex Process-Based Models using Multiple Datasets. So what I'm going to do in this presentation is give you a little bit of background about the project and then give you an update as to where we are at the moment. So the phrase on the left here tries to summarise what we're trying to achieve on the project. Mathematical models are used for lots of different processes, but how can we calibrate them to the real world, make them accurate models for real world processes, and then how much trust should we place in predictions that come from those models? So this project, I guess, I'm trying to show here where it fits in this diagram into the entire process of making decisions about landscape. So the whole process, of course, involves all sorts of different factors and different pieces of information, and one of those is models. We'd like to use models for different processes to inform our decisions and maybe help us predict what might happen. And part of that modelling process is to calibrate the model, make it realistic, so that if it's got tuning parameters that they're realistically representing what's going on in the world, and to quantify the uncertainty about the outputs from the model. And a way of doing that is the class of techniques that are being investigated in this project, which are called approximate Bayesian computation, ABC, or particle filters. Okay, so that's some background. So next, a few thoughts about what we've been thinking about in the past year in the project, things that are informing the way the research is shaping. So I guess two of the key ideas about that are crucial for this project is that, or crucial for using models for making decisions, is that we would like them to be accurate. We'd like the models to be a good representation of reality. So we know that if we base some decisions on these models, then we're basing them on kind of accurate information. So accuracy is important. We want to be able to trust the outputs, but we also want to know how much trust we can place in these outputs. So about some of the outputs will be very accurate, and we can say we're very certain, but about other things we might not be so certain. We'd like to know when that's the case, to quantify that uncertainty. We had some very useful workshops last year in the landscape decisions program about the types of models that are used in the landscape setting. Because I guess a lot of these questions also arise in models used in different settings, such as for the COVID pandemic or all sorts of other settings. So for landscape models, one of the main things we picked up from last year was that the sets of models that are used are extremely diverse. We've got models based on differential equations, individual based models, statistical models, and if we want to provide tools for people to be able to calibrate and make predictions from these models, then we are going to have to be able to deal with all these different types of models. The other thing we've picked up, which I guess isn't actually landscape specific, but there's often the process that happens is that the model is constructed before the parameters of it are inferred. So there's a lot of work goes into constructing accurate models. But when you, from a statistical point of view, the ideal thing to do is to infer the parameters of the model as part of the model construction process. So you might come up with a model and try and fit it and see whether it's accurate, and then you might refine the model based on how well it does. Now, obviously, that process is going on a lot in groups that construct models, but for some models, it's very difficult to do this because they're very expensive. And so it's difficult to use this inference process, this calibration process, to help inform building the model. So this project is all about developing tools to help with these issues. So what have we been doing? Waiting for it to switch to the next slide. We've been looking at two things in particular. So firstly, we've been looking at improving the algorithms that one might use to calibrate the models. And the reason we're focusing on that is that if we can do this faster computationally, then we hope that it will be able to help people refine their models based on the results of this inference. If the inference process takes a very long time, it's not really realistic to involve this step in the model building process. So we've been looking at improved algorithms to really help this become part of the model building process. And then the other thing we've been doing is focusing on software. So trying to make it so that the tools that we're developing are available to people. And so here's a couple of pictures of GitHub of packages that are being developed by the project. And two of the things we're focusing on are making sure that we can deal with models that are in all sorts of different languages: Python, R, NetLogo, Julia, C++, Java, and to make sure that for the cases where these models are expensive to run, that we can use parallel computing where possible. So work's ongoing on these packages, and once they're a bit more mature, we'll be looking to produce some case studies in applying them to problems in landscape decisions.